Hello, I'm going to be showing how I recreated the Mystify screensaver effect in 3 dimensions in Neos VR using the LogiX visual scripting language. And if you don't know from the name what the Mystify screensaver effect is, it's that. I'm sure it looks familiar even if you didn't remember the name. I know I had to look it up. And if you're wondering what it looks like in 3 dimensions, well, I already have it working. So that's what it looks like. Now, I actually took quite a few hours of video while I was creating that to show how I figured out how to do it. And even after editing, it was too tedious for almost anyone to watch. So this is going to be a short summary video, just going over really quickly how I made it work. There are several parts that we need to pull together to make this work. So I will just show how each of those individual parts was made to function.
Now this may look like the movement is a little bit complicated, but if I highlight just the points on the corners here, you can see that all it's doing is basically bouncing around a bunch of points around the screen, and it just happens to draw some lines in between them.
I'm going to start with a sphere, and we'll see if we can make that bounce. Before we can make it bounce, I guess we need to make it move. Okay, here is the very simplest example I can think of making something move using LogiX. So we have a sphere here. We take its position, we add a velocity to it, which later we'll put in a variable, but right now it's just an input, and I only have it moving in the X, it's not moving in the Y or Z directions. And we have an update node to do periodic updates to it. Every time the update fires, it will add velocity to position and write that back out into position again. So if I hook that up, it takes off. Now, if you want your moving object to bounce, it gets a little more complicated. I have an example over here. So up here are the nodes required to make it move. So all it does is, on an update, it adds the velocity, which is now stored in a variable, to the position and writes that back out into the position. But to make it bounce, after that write is complete, we go down here. So after the write, it comes down here to the sequence, which just does the same set of operations to the X and Y and Z. So it checks to see if the X, Y, or Z position is greater than the limit we set. So we take the new position, absolute value of it, we unpack it into X, Y, and Z components, and we compare it to this 0.5 back here, which is what we have set as the limit for this bouncing ball to stay inside. So if one of those 3 components exceeds 0.5 in either direction, less than negative 0.5 or greater than positive 0.5, comes down here to where it is reversing the X, Y, and Z components of the velocity. So it's taking the value out of the velocity, unpacking it into X, Y, Z, multiplying each one by a -1. So this one, and then copying the other 2 values back in unmodified. So this node has only the X component reversed, this is only the Y component of the velocity reversed, and this is only the Z component of the velocity reversed. Those 3 if nodes are hooked up to these 3 velocities with only one component reversed. So if X is out of bounds, comes down here and writes a reversed X, X multiplied by -1 into the velocity. If Y is out of bounds, it flips only the Y velocity, and if Z is out of bounds, it flips only the Z velocity. And of course, if it happened to hit a corner and all of them went out of bounds at the same time, it would flip all 3 of them in sequence one at a time. And that's all there is to the bouncy ball. What we are doing is trying to connect 2 points with a line. So basically draw a line between 2 points, except in 3 dimensions. And we have an example here. So this is fairly simple, and it uses mostly components, not logics. If we look at this, we've got 2 spheres, and the cylinder is the line connecting them. And on the cylinder, there's a component called, down here, line transform. And what that does is it will keep the cylinder in between the 2 anchors. So 0.0 anchor is one of the 2 spheres, 0.1 anchor is the other sphere. And we set it to be equidistant between the 2, so we set its line point to 0.5. Now 0 is at the same position as one of its anchors, 1 is at the same position as the other, so 0.5 is halfway in between. And all that's left after that is to make it the correct length to span the 2 spheres. So on our cylinder, which is forming the line, we make sure that we set its height to exactly 1, so height of 1, and that makes the math simpler, and we do the rest of logics. You can see we have a reference to sphere 1, a reference to sphere 2, and a reference to the cylinder in the middle. All we do is we take the distance between the 2 spheres, multiply the y scale of the cylinder to be the distance between the 2 spheres, and put that into the scale, and we're done. It works. There you have it, drawing a line between 2 points. If it glitches when I grab it, but that's because when you grab something that's being set as like a child of your hand or something like that, if you move the points programmatically with logics, it won't glitch like that. But you can see no matter how far apart I put the 2 points, it maintains the distance between them. And now that we made the points on the end and the line the same radius, it's got a nice smooth look, like a line with rounded ends. Not really a line, it's like a volumetric line. Working on the next part of the Mystify screensaver effect. If you look at the actual screensaver, though, it's not one line, it's a set of a few lines, I don't know, 4 or 5 or 6 following each other as they go. So we need to implement that part of the effect. Okay, renamed it follower 1. Now what this has to do is whenever this gets its position updated, which is what this right node right here does, this one should go to its previous position. What we may do is put a sequence in between the if and the right, and the first step will copy the position of the leader to the position of the follower. Oops, didn't mean to open that. And then the second step will do the right of the new position for the leader. Let's try that and see how it works. Okay, this one's already set up. This one, we're taking this guy's position, copying it to this one. Then we're taking this guy's position, copying it to this one. This guy's position goes to this one. All right, where's my turn on? There's my turn on. That's what the effect looks like with no lines. Okay, this is an example of setting the positions of a whole bunch of objects using slot logic, so you don't have to have any references to the individual objects you're moving. I've gone in and given each of these boxes a tag, and the tag just says move me. And then on the parent object that contains them all, we have this logics. So all it does is loop through all of the children. So take the children count, set up a for loop for each iteration of the for loop, get the child, see if the child has a tag, which is move me, so it will only pay attention to the children with a move me tag. And if it has that tag, it takes a random float from negative 0.5 to 0.5 and sets the position of the child that it found. And that's hooked up to a button event right now. I can click that. And every time you do, it loops through all of the children. If they have the tag move me, it sets them to a random position between negative 0.5 and 0.5. I really like this example because prior to this, I had not used in Neos LogiX a for loop or a random or anything to do with slots, and yet it was so simple to use and works very well. All right, well, I just did an example of how to have a color on an object changing smoothly over time. And then I realized that I did a really bad example because I did it, probably 20 times more complicated than necessary. See this thing here? This is working, but all of the nodes below this point are basically completely unnecessary. So let me explain what we have here that actually is needed. So we have these 6 nodes at the top. Those are generating a random color. You've got a 3 random floats from 0 to 1 packing into the RGB values of a color. Alpha is always 1. And then every 5 seconds, this timer here fires and writes that random color into a color variable, which is right here. And I just have a thing displaying so you can see what the color is that's in the variable. And I had all that logics below to make the color of this cube change slowly over time to match what's in the variable. And then I realized it's all totally unnecessary. So instead of that mess of logics that we had, all we need is a thing in one of these categories called the smooth lerp. So we take the smooth lerp for its target. We take the target color out of the variable. Its destination goes into the cube there. And we give it a time to say how fast we want it to change. Say 1. There. And if you want any more details, you can watch the super long videos, or you can log into Neos VR and come see it in this world that I'll be submitting. So we have the effect up there. And over here, we have examples and videos. So this video that I'm recording right now will go there. So, part 1 videos with logics, part 2, part 3, so on. I haven't done the videos for these last parts yet. I don't know if I'll have time to do that. Since this is Neos and we can change everything in the world, I have something I want to try real quick here. Okay, camera, you're looking at me. Now I'm wondering what happens if I attach you to one of the nodes on this Mystify effect. Goodbye, camera. Have fun on your journey. I have no idea what the view is like from up there. I mean, I suppose I could make these climbable, and then I could go up with you.